Welcome back. We just were talking about the different memory reclamation techniques that the ESX server has, and then the memory reclamation performance indicators that you can monitor using ESX Top. Here we can then start talking about what to do when you have these situations. Now, basically, the solution for any one of these is to basically reduce the load on the system, right? The cause of host level swapping is that there's just simply too many VMs based on what memory you have on the host. There's too many VMs that are looking for memory that is non-existent. So you've overcommitted memory beyond the abilities of the system. This could be due to just the fact that the amount of VMs is greater than what the hardware can handle, and we missed the warning signs such as ballooning and compression, and now the system is now at swapping, which is basically last resort conditions here. So we want to be able to detect this, right? And again, hopefully you catch the warning signs like ballooning and compression first before we get to swapping. So resolving host level swapping is as always the simple choice of reducing the load on the system or adding hardware to the system. But reducing load is always easier. It's usually just simply running a vMotion, right? Reduce the level of memory over commitment, use vMotion. Always have the balloon driver enabled. That helps too, because then we can at least try to use that to help us find those idle memory pages before we get to a point where we are at that swapping stage. But, sometimes every host may be running low on memory, so now we do need to add hardware to the environment. Adding a host to a cluster is sometimes another approach. Or simply scaling up and adding memory to a host, or all your hosts for that matter, as opposed to scaling out by adding a host to the cluster. Of course, reducing memory reservations can help, because as you add reservations, you're basically locking down memory that no other VM can use, which then may cause contention for those VMs who don't have reservations. And resource controls are typically the last resort too for an administrator. We generally don't want to have to set reservations and limits and shares as a general practice. There are ways of ensuring for certain critical workloads that at least they have some minimum resources granted to them. So reducing memory over commitment, like we said, it's simply enough. It's vMotion. But if you can't vMotion because all your hosts are already saturated, then it's time to consider scaling up or scaling out by either adding memory to a host or maybe adding a new host to the cluster. Making sure the balloon driver enabled is always a critical first step for any environment. The balloon driver allows the system to hunt down that idle and free memory that the system isn't able to use in one VM, so it could then give it to the more busy VMs. So it's always a best practice to keep that balloon driver enabled, install VMware tools, and then keep that balloon driver enabled. And as I mentioned, reducing the memory reservations, being conservative with those memory reservations. The higher you set those reservations, the less VMs you're going to be able to run. But then the VMs who themselves that don't have reservations are going to have to be contending for whatever memory there is. And that may cause them to be forced to start paging maybe sooner than you would like. So for those critical VMs is where you really focus on setting those reservations. And again, you're doing this to meet some simple SLA, make some basic requirements to make an application viable, to get it able to be started, initialized, and start performing basic tasks. You don't really necessarily want to grant a VM such a large reservation, because then that's going to increase much stricter admission controls, making it so that this VM requires so much memory just to power on, and then restricting memory from effectively all the other VMs on your system. And the end result will be that you'll run less VMs. So to demonstrate some of these memory reclamation techniques, we've set up a neat little exercise here to demonstrate this. You may be familiar with this VM called Linux 01. We just used it in the CPU monitoring exercise. We actually used Linux 01 with that start test utility, right? Here we'll use that same start test. We'll use start test 2. We're going to run the VM all by itself to grab some baseline. The VM should run just fine all by himself. But then you're going to start 2 more VMs on the same host. So just make sure before you go and do the lab that all the VMs are on the same host. They actually should be on host number 4. I know the picture says host number 1, but they should all be on host number 4. The Linux 01 is probably already on host number 4 because that's where he was when we did the CPU lab, but those resource hogs, they might be on another host. So just make sure they're all on the same host. But notice something about those resource hogs. They're both 4.5 gigs of memory, and our Linux 01 is 1 gig. and our host only has 8 gigs. So we're overcommitting the server here in the goal to see the different memory reclamation techniques. So you're going to grab baseline statistics first with Linux 01 all by himself, then start the 2 resource hogs. They're meant to run the Ultimate Boot CD, which has a bunch of stress testing tools on there. One of them is the Memtest 86 Plus, and that's the tool you want to use. So just to make sure here, let's actually jump over to the lab environment to show you what you need to do to get those resource hog VMs up and running properly. So here we are in the lab environment, and I've selected host number 4, and I've made sure all the VMs are on that same host. That's where they should be. And that's what we're trying to do, is creating contention on one host, right? But the thing is, when it comes to these VMs, they are meant to boot off of this Ultimate Boot CD. So they have no hard drive. They must boot off of their ISO image that's mapped to them. And the thing is that you actually have to tell it to do it within a few seconds of having booting the VM. So they don't default to this. So here's what I recommend doing. Just power on the VM and then quickly open up a console to that VM. The lab's going to tell you this, but I'm just showing you just so that you don't miss it, right? You'll find the VM will be essentially, booting up off of its boot drive. This is where, when you see this, just hit enter. You don't have very long to react to that. So if you let that sit for too long, it'll time out and then the system just won't boot. So that's the trick. You just need to hit the enter key as soon as you see that boot colon prompt. And then you go ahead and enter into the menu. You want to go into the main board tools, then go into our memory tests, and then we want to launch Memtest 86 Plus. This generates a whole lot of memory activity on this VM. We're going to need to do this on 2 different VMs so that we can really chew up the memory on that host, causing a lot of memory reclamation. So here's what we need to do, though. We'll switch back to our slides. We're going to record baselines with the machine by itself, and then we're going to add the contention, right? So these are our steps, right? You're going to gather the baseline with the database activity with the test VM all by itself, and then we're going to check what kind of overcommitment there should be. At this point in time, there shouldn't be any overcommitment. You'll get the baseline memory stats, and then in task 5, we'll have you launch that resource hog 1 and 2 on the same host and see what happens. Now, what we want you to record are things such as, is the Balloon driver enabled in any one of those VMs? Well, we should find the Balloon driver is already enabled and running in the Linux VM. It shouldn't be running in any of those resource hogs because they boot off of an ISO where we can't install any software. The Balloon statistics should all be 0 for those resource hogs, but when there's contention, the Linux VM will probably have some activity there. The swapping should be something that appears in all 3 VMs, though, because we are going to run short on memory across the board here, so there will be swapping activity. And the swap weight will also probably show some details too, because if the system does run low enough of memory, the CPU monitoring screen should probably report that VMs are being blocked for allocating memory, so they'll be in a swap weight condition. So the goal of this exercise is to watch all of this happen, right? Kind of watching all the different reclamation techniques do their initial stages in a predictable order. And then how do you know when you're done with this lab? That's the other big question, because essentially the solution is to either move 1 or 2 VMs off of the host or shut 1 or 2 of the VMs down, right? Add hardware to the solution, right? I mean, we're not having you actually do any of the corrections. We're here to actually watch the actual memory reclamation techniques show up in the ESXtop report. So when you're done is when the numbers start to stabilize. They're going to start to normalize when you have, for instance, the balloon size and the balloon target. They're going to eventually get close to converging. They may never converge, but they'll get close, and then you'll see, okay, they're not changing. Once they start to basically stabilize, then that's it. There's really no more else you're going to go in the lab. Same thing with the swapping statistics. You'll have what's the current amount that the VMs have swapped and what the target is. The current should get close to the target, but it may not. But eventually, the current will stop increasing, and then the systems has basically said, this is all we can do. We're pretty much done what we can do. And so the systems have been now normalized. So that's how you know when you're done. It's basically when the numbers just stop increasing for those target values. And that's what you're going to be doing here as we go through this exercise, just to kind of see each of the different stages. So we covered in our lesson here how to identify key memory metrics to monitor, how to use metrics in the ESXtop tool, monitor host memory usage and virtual memory usage, how to monitor host swapping activity, and monitor host ballooning activity, which then this actually ends our memory optimization module, understanding that the hypervisor uses memory reclamation techniques such as ballooning, compression, host level swapping to all reclaim host memory. And those host swap rates and ballooning activity are key memory performance indicators. They should all be 0, by the way. There is no number that you need to keep them below. They need to be 0. And the basic cause of host memory swapping is a combination of memory overcommitment and memory intensive VMs. You basically have launched too many VMs that need memory beyond the needs or the capabilities of your system. So that ends this module. Go ahead and perform that lab exercise, and we'll see you in the next module.